What's up, everyone? It's your boy Zarchar, and today we got another banger of a tutorial for y'all. Pretty much, Victor Conde 684 asked if I could make a tutorial on sliding a Mario Kart car with a booster. And that's precisely what we're going to do today. So today we're going to go over three things. The first thing is we're going to do very basic Mario Kart movement. Then we're going to do drifting, and then we're going to add drift boosting. So without further ado, let's get right into this. Alright, so let's start off by utilizing a template. Now, everyone's first instinct whenever you're trying to create a vehicle movement system, especially, something like Mario Kart, is you always want to go for the vehicle template. But here's the problem with the vehicle template in Unreal. Unreal's vehicle template is for racing sims. So your Gran Turismos, your Forzas, that's what the vehicle template's really for. And Mario Kart's movement and racing movement isn't really that realistic. It's more of an arcadey game. So because of that, instead of using the vehicle template, instead we're going to use the third person template because we want to have a lot more control over our movement. And instead of having a lot more influences on it, say for example, one of our wheels went over a little bump and now we lost 5 miles per hour or something like that. That's not really a movement system we want to pursue. Instead, we just wanted to the extent of our movement system in terms of terrain manipulation is, hey, if I drive on dirt, I slow down. If I'm not on dirt, I'm at normal speed. And then I have coins that might speed me up or slow me down. Who knows? But anyways, enough yapping. Let's go ahead and create our project in third-person template. As always, make sure your quality preset's on scalable. Again, there's a lot of stuff in Unreal that you don't really need, so scalable will make sure that you can quickly disable those. Let's not include our starter content, and of course, make sure it's not ray tracing. Alrighty, so now that we're inside the project, the first thing we're going to go ahead and do is we're going to go inside our blueprints, and we're going to go to a third-person character. Now, we have to do a couple of things real quick to the movement system to make it feel like Mario Kart. So the first thing we're going to go ahead and do is, before we touch the movement system actually, is we're going to touch the camera. First off, camera input doesn't exist. Instead, your camera effectively follows your car through the racetrack. So we just need to delete that input stuff, and then we go back into our camera boom right here, and we turn off use pawn control rotation. And then we tap into our viewport, press E on our keyboards, drag this up, drag the pitch down by -20, and what that's going to do is that's going to give us a nice viewpoint. If we compile save this, pretty much now we have a nice viewpoint of our character. Now, next thing we need to do is we need to fix our movement. So pretty much right now our movement is very much like a person. You can walk forward, you can walk left, you can walk right, you can walk backwards. But you can't do that in a car. In a car, you pretty much either move forward or backwards, and then you have your steering that modifies your turning radius and which direction you go in when you move forward or backwards. So let's go ahead and set that up. So the first thing we need to do is, in our event graph, we want to go to our movement input. Now, first thing we want to do for our left right is we want to delete all of this stuff. And then for our forward backwards, we just want to delete these two nodes right here, get control rotation, get forward vector. Instead, what we're going to do is we're going to type in get actor forward vector. And pretty much what that's going to do, and we're going to attach this into this add movement input. And what that's going to do is, because this is our forward backwards, pretty much all this forward vector does is it gets our current forwards. And because in a car, whenever you move forward or backwards, you pretty much move forward or backwards in the direction your car is rotated in. So this is the perfect solution for us. And before we reconnect the execution line back to our triggered on event IA move, first thing we're going to do is we're going to add a branch, and this branch is going to be used for later, and you'll see how. So for now, just keep the condition as true as nothing. And then what we're going to do out of this true node is we're going to get a function called add actor world rotation. And then from our delta rotation, we split the structure pin, and pretty much for our delta rotation Z, we get a lerp. And in this lerp, what we're going to go ahead and do is our alpha is going to be our X value, because X in IA_move is left right. And pretty much what this is our turning radius. So A is going to be 0, because if we have 0 input from the controller whatsoever, or the joystick whatsoever, pretty much we just want to move straight, right? But for B, this is kind of like, okay, we are flatly moving left or flatly moving right with our joystick, which direction do we go? So our B is going to be our maximum turning radius. So we're going to promote this to a variable, so that way you can, like, if you have different car variations, or you just want to fine tune this as a designer, you can easily do that from a variable. Pretty much what we're going to do is we're going to call this max turning radius. And let's make this, just for the sake of debug, 1. Now you can fine tune this based on different cars or based on like your personal preferences, but this should be good. And then what we're going to do is once we do that, we're going to drag out of add actor world rotation, put that into our add movement input. And then what we should happen is if we start playing the game, we now move like a car. Hooray! Now, obviously this is the most human-like car you've ever seen. Nothing turns this great. Again, if you want to kind of fix that, you can change the max turning radius down to say something like 0.5. That'll be a little more restrictive in terms of what you are able, on how you're able to turn. So now you turn less quickly. And yeah, that's perfect. Now the next thing we need to do is we need to go into our character movement and we need to make ourselves act more like a car. So a car doesn't accelerate instantaneously. Instead, it only accelerates over time. So let's change this down to 400 units. And then what we're going to go ahead and do is we're going to make our maximum speed to something more like 2,000 units. And that might actually be a little bit of overkill, so we're just going to do it 1,000 units. But what this should let us do now is if we start playing the game, is now we start very slow, but as we keep on moving, we now have a fast speed. Hooray! Now, real quick, what you might notice is if you move backwards, we currently run into this bug, where basically we don't know what to do with ourselves because our rotation is at 0, and yeah, it's just a mess. So let's go ahead and fix that. So the reason why that's happening is because if we go back to our character movement, pretty much what we're doing right now is we are aligning our rotation to the movement. So when we start moving backwards, what actually happens in the character movement is the player actually turns around as they move backwards and then start moving backwards because of our acceleration. So the way we fix that is we disable orient rotation to movement. Since we're already rotating left and right and all we're really caring about with the movement system is forward and backwards, this is just a quick and simple fix. And what should end up happening is if we move backwards, we do in fact move backwards. So we can move forward, and then we slow down and we start moving backwards, and then we're good. Sweet. So now we pretty much have a very, very basic car movement system. Again, fine-tune the values to what you want. There is a couple of things, though, we have to fix. First off, whenever we're not moving forward or backwards, we're pretty much able to still rotate. And maybe if you're making a tank game, that might be nice for you. But if you're not on tank treads, this is practically impossible. And we don't want that to happen. And the next thing we also want to do, though, is as I'm turning, there isn't a movement penalty. So normally whenever you turn whenever you turn a vehicle in Mario Kart, you actually lose speed. And this is true in real life as well. And the reason why is because your movement is actually not all going forward, instead because movement is normalized, and because of that, so you actually lose some of your speed because because let's say for example your movement vector needs to equal 1, because that's where all your power is going, but your power is also being shifted to for example the left or the right. All right, so let's go ahead and fix those two issues. So first, let's fix us turning whenever we are standing still. So the way we do that is quite simply, we go ahead and we get our velocity. And then what we do is once we get our velocity, we get the vector length. And then pretty much once we get our vector length, we just check to see if it does not equal 0. Then once we get that, the next thing we're going to do is we're going to drag this lerp down by a little bit. And then from delta rotation Z, we drag out. And then we type in select float. And you can pretty much see where this is going. What we're going to do is we're going to put the lerp into A. And then long story short, what happens is if our car is moving in any way whatsoever, we will pick our, we will basically consider what our turning radius is. However, whenever we are not moving whatsoever, then do not rotate at all, and thus we want to pick B, which is 0. So anyways, once we get our does not equal 0 down here from our vector length, we're going to drag this into pick A, and boom, that's pretty much set up. So if we compile this and save, what should happen is if we play the game, we still move normally, and then if I press A or D on my keyboard, I can't move left or right. Perfect. So the next thing we need to fix is is normalizing our vector, because right now, even when I turn left and right, I do not lose any speed, and that's not how driving works. So let's go ahead and fix that. So the way we're going to fix that is from our scale value here in the add movement input and forward backwards, we're going to drag out of that, and we're going to get a subtract node. Then what we're going to do is from our action value y, that's already in this giant reroute line right here, we're going to put that into the top node of the minus, subtract. And then what we're going to do is from the other node, or the B node, we're going to drag out, and we are going to get another lerp. And then this lerp is going to go from 0 to 0.5. So the way this works is pretty much if we are going straight, then this value will be 0. But if we are going to the left or the right, or dead to the left or dead to the right, then this value should be 0.5. So what we're going to do now is we're going to get our x value, we're going to drag out from here, and we're going to plug this into our alpha. Now there's going to be a problem with this, and we'll show it in a second, but in theory, let's go ahead and turn to the right. And as you can see, it works. And then when we turn to the left, it actually makes us move faster. Now you might be wondering why does it do that? Well, that's because the way a linear interpolation works is it pretty much plants a point on it makes a line based on the A point and the B point. And if the alpha value is below 0 or above 1, well then it keeps on going down the line in that direction. So what happens is whenever we turn to the left, our x value is actually -1. And because of that, our alpha is -1, which means in reality, we're subtracting -0.5, so our scale value becomes 1.5, which is not good. So how do we fix that? Well, that's a very simple node. Just go ahead and drag out of this reroute node down here for x, and we're going to drag out and we're going to type in ABS. This will basically give us an absolute value, and then we plug that into our alpha. And then that will fix things. And finally, just as one last way of fine-tuning, if you have different cars or you just want to fine-tune this value, promote the B value in this lerp to a variable, and call this speed reduction when turning. And you should probably put max in front of speed. So the actual variable name is max speed reduction when turning. Very long, I know, but it's useful. But basically what this variable will let you do is it will let you fine-tune how much is that penalty whenever you are turning. So instead of 0.5, you could put this down to 0.3. So now there's less of a penalty for turning. Or if you have a car that should never turn, it's really good at moving forwards whenever it turns. All of a sudden, it's like a drag car effectively. So all of a sudden, it doesn't know what to do. Well, then maybe you can make this 0.7. And then when we play the game again, we effectively come to a screeching halt. Perfect. Now, most racing games get played on controllers. And right now, if we go ahead and I just plugged a controller into my computer. If we play this game, well, let's just say it's not the smoothest experience. Any slight change in your movement in your thumbstick is not that great, and it's very difficult to steer. So let's go ahead and fix that in our controller input. So what we're going to go ahead and do is we're going to press Control Spacebar, and we're going to go to Input in our third person folder, and then we're going to go to Actions, and then we're going to double click I_move. Once we open that, the first thing we're going to do is we're going to go to our modifiers, open that up, and we're going to add a dead zone. And what this is going to do is this is going to make it to where effectively any small change in your input no longer affects you really badly. So because of that, now you as a controller player don't all of a sudden see your character just moving around all the place. Now your actions have to be immediately decided upon in order for it to work. So yeah, now it's a little bit better of an experience for our controller player, which is perfect. Now, what you might be noticing here is pretty much we don't actually have our acceleration is on our left thumbstick. And the problem with that is the player can get so slow with the left thumbstick that eventually they can effectively turn like a character. And we don't really want that. So how do we fix that? Well, the solution is actually quite simple. What we're going to go ahead and do now is if we press Control Spacebar, we go back to Input, go to IMC_default, and the first thing we're going to do is we're going to go to we're going to open up our I_move, and the first thing we're going to go down to is we're going to go to Gamepad left thumbstick 2D axis. We're just going to change this. So open up this drop down, go to Gamepad, and then go to Gamepad left thumbstick X axis. This is going to make it to our left thumbstick steers the car, but it doesn't actually handle the acceleration. So now we need to add inputs that handle the acceleration. So to do that, what we're going to do is we are going to add a new control binding to the action mapping. So let's go ahead and open up the drop down, go to Gamepad, and let's get Gamepad right trigger axis. And what this is going to do is this is going to handle our acceleration. So if the player presses this button, we're going to move forward effectively. So now in order for that to work, we have to add a couple of modifiers. So right now, the way that inputs work is when an input value is only just one dimension. So for example, a gamepad right trigger axis is a float between 0 and 1. It will always default to the X value in the input action. But that's a problem for us because our input action, the way we move forward and backwards, is we actually have to get it to our Y value. So how do we map that? Well, the way we do that is we go to our modifiers, and this is a weird name, but it's how we do it, and it's called swizzle input axis values. And what this is going to do is this is going to move where different axis values are mapped to. So normally it's X, Y, Z, and then we can change it to a different type of order. So in this case, we want it to be YXZ. And what this is going to do is now if we go into a third person map, press play, if we hold right trigger, we now move forward. And then we can use our left stick to steer. Perfect. And finally, the last thing we need to do is we need to move backwards. So let's go back into our IMC_default, add another input action. Then open up this drop down, go to the gamepad, and then we're going to get our left thumbstick axis. Or sorry, not left thumbstick, sorry, right trigger axis. Gamepad right trigger axis. Or sorry, left trigger axis. I can't speak apparently. Anyways, once we get that, the next thing we're going to do is we're going to go to our modifiers, and we are going to once again swizzle our axis, get a swizzle input axis values. Then what we're going to do is we're going to add another modifier, and we're going to get a negate. And what this is going to do is this is going to set our value to a negative number. Since we're moving backwards, we need it to be a negative value, and this is perfect. So then once we go and press play, we press left trigger, and we move backwards. And when we press right trigger, we move forwards. Perfect. So now we have a very simple movement system and for a car. Congratulations. Now, the next thing we need to do is we need to get drifting set up, because one of the main core mechanics of Mario Kart, in addition to driving, is also the idea of drifting around corners and then using that drift to get a speed boost on the other side. So let's go ahead and program that. So let's hop back into our BP_third person character. And if you remember this branch I made you place earlier, now we're going to finally use it. So right click on this condition, promote that to a variable, and we're just simply going to call this drifting ? And pretty much when we're drifting, we're actually going to have a different set of logic for how we are moving, if that makes sense. So pretty much normally this is our normal movement, but when we're drifting, the way it works in Mario Kart is you're always moving forward, and pretty much your left and right input only modifies how far to the left or how far to the right you're drifting. So if you're drifting to the right and you hold down your left and you slam your left stick all the way to the left, well then you're not actually going to move to the left. You're going to actually move only slightly to the right while drifting. So let's go ahead and set up all of that logic. Once we get this boolean, once we have this boolean value here as a variable, then what we're going to go ahead and do is we are going to go ahead and hijack the IA underscore jump event. And the reason why is because jump consumes an input when we press the input action, and it consumes an input when we release the input action, which is perfect for when we want to press and then release our drift action. So let's go ahead and open up this drop down for enhance input action IA underscore jump. And on started, which will fire when we press the button, we want to set drifting to true. And then completed will fire whenever we release the button. So then we want to drag our drifting, put that to completed and set drifting to false. And now we have our very, very basic code for starting our drift and then ending our drift. So once we have this set up, well, now we need to set up our actual drifting logic. So the way we're going to do that is we're actually going to do this off event tick. So get yourself an event tick. And then what we're going to do is we're going to get a branch. And our condition on this branch will be whether or not we're drifting. Now, real quick, compile this blueprint, make sure and set your default value for drifting to false. I just realized I forgot to add something. Back up here in your movement input, so your IA underscore move. From this drifting conditional, drag drifting down a little bit, drag out of drifting, type in not bool, and then from this not boolean, drag that into the condition for the branch. The reason why is because we want drifting to be true whenever we are in fact drifting, and we want it to be false whenever we're not drifting. Now that we got that fixed, we are now back down here on the event tick and this branch. So whenever we are in fact drifting, we're going to go down this true node. And effectively, our logic flow is going to be the same from our movement input. Basically, we're going to rotate the actor, or in this case, our car, in a direction based on how we're drifting. And then we're going to add a movement input. So let's go ahead and go back down to this branch. And the first thing we're going to do is from true, we are going to add actor world rotation. And pretty much, the drill, right click on the delta rotation, split the structure pin, and then we're going to do things off of delta rotation Z. Now, again, the way that drifting works is whenever we start our drift, depending on which direction we're moving, well, we can't drift into the other direction without releasing our drift input. So in order to get that set up, well, first off, we need to check to know which direction we're drifting in the first place. So let's go back up into our IA underscore jump, and off of whenever we start to drift, we're going to go ahead, right click, and type in IA underscore move. Now, we don't want the enhanced input action event, we just want the enhanced action value. And the reason why is because this is just a pure function that gets us the value of whatever our input is. So let's split the return value structure pin, and what we want to do is we want to read the value of x, because this is our left or right. And pretty much what we're going to do is we're going to create a new variable. We'll call this drift right, question mark. And pretty much all we're going to do is we're going to drag drift right, add it to the execution line after we set drifting to true. And then what we're going to do is pretty much we're going to check to see if our return value x is greater than or equal to 0. And then plug that return value into drift right. So now we can effectively tell whether or not, hey, are we drifting right or left? Now that we got that set up, we're going to go back down to our event tick, and off of delta rotation Z, we're going to get a select float node. And pretty much what we're going to do is for pick A, we're going to drag our drift right into pick A. Now, what this is going to do is if we are drifting right, we select our calculation for if we're drifting right. And if we're drifting left, then we select our calculation if we're drifting left. And that's why we have this select float here. So what we're going to do is out of A, we're going to do our drifting right calculation, and that's going to be a lerp over 2 values and an alpha node. So the way we're going to calculate this is A is going to be the minimum turning radius when you drift. So let's say, for example, we're turning to the right, we're drifting right now. If the player is steering all the way to the left, but they're still holding down the drift input, this is how far to the right we will be moving. So let's promote A to a variable, and we're going to call this min drift turning radius. Compile it, and let's make this a low number like 0.1 or 0.2. I'm going to set it as 0.2. Then for our b value, the way we're going to do this calculation to catch some edge cases that can happen is our b value is actually going to be our center. Whenever the player is not putting any input in for their steering while they're drifting. So to do that, what we're going to do is we're going to right click on B, and we're going to call this mid drift turning radius. And effectively, this is going to be our drift turning radius whenever we have 0 input. And the reason why we're doing that is because we are, again, if we go back down to this graph, right click, type in IA_move, get the enhanced action value and not the event, and let's put the structure pin. What we're doing is we're just simply going to get our x value, and then we're going to do a linear interpolation. In our linear interpolation, our alpha value is actually going to be the x value. Now the problem is that the x values can be both positive and negative. So the way we get around, hey, we are drifting to the right, but our steering wheel is all the way to the left. The way we get around that negative value is we add 1. But when we do add 1 to the input action value, well then, if we just made B our maximum drift turning radius, then what's going to happen is we're actually going to go beyond that when we are turning to the right. So that's why we have B as our not adding any steering input drift turning radius. Anyways, from our x value, we're going to drag out. We're going to get an add node, and we're just going to add 1 to this value. And then we're going to drag from this return value into our alpha, and now we have our drift right input, which is great. So let's go ahead and test this out real quick. Let's go into our third person map. Also, sorry guys, before we do that, wait. Go back into your event graph and make sure your mid drift turning radius is something like 0.4 or 0.5. And then finally, just as one last thing on my end, because I forgot to change this back, I'm going to go back to my max turning rate, max speed reduction when turning. I'm going to put this back down to something more reasonable, like 0.3. Anyways, back into the third person map. We're going to go back here, and I'm going to press W, and when I hold spacebar, now we're drifting, and now we're turning. And if I'm holding left, we turn less, and when I hold right, we're turning more. And if I start using my controller, we can actually see that we actually have a lot more smoother movement, which is perfect. Now, just as one last thing, because I forgot to add this, before we calculate our left version of the drift, we're going to quickly just go off this add actor world rotation on the execution line, and we're just going to simply add movement input. And then our world direction is going to be get actor forward vector. And now if we go back and press play, hold W on your keyboard, press spacebar, now we have drifting. And then if we hold if we hold left on our keyboard, it's less, and when we hold right, it's more. Perfect. And now, finally, on your controller, test this out as well. So on controller, the input action is going to be A. So hold A. And as you can see, it's working. Perfect. Now, let's go ahead and calculate that left rotation. Or sorry, that left drift. So from B, we're going to drag out. And once again, we're going to get another lerp. Now, left input values for return value X is actually going to be negative. So because of that, whenever we are drifting to the left, we actually want our min drift and mid drift turning radiuses to actually be negated. So the way we do that is, let's go ahead and just as a quick shortcut, so all you'll know this, if you hold control on your keyboard and drag a variable out, it automatically does a get node. So we're going to drag out our min drift turning radius, and we're going to drag out of the return value, get a multiply node, and then just multiply by -1. Perfect. And then we're going to put that into A, and we're going to do the exact same thing with our mid drift. Drag out, same thing, multiply, -1. There we go. Put that into B, and just like that, we got that set up. Now for alpha value, what we're going to go ahead and do is we're actually going to get our x, negate it as well, so multiply by -1. And then we're going to do the same thing where we add 1. And then we have our calculation for drifting to the left. So now if I go back into the game and I press play, I'm drifting to the right, and then I can drift to the left. Perfect. Now, if you do want to do any sort of scale value manipulation based on what, just trying to normalize the vector, pretty much you would do the same thing you're doing in the movement input section of the code with this lerp on the absolute value and the max speed reduction and the minus, yada yada yada. You would just copy and paste that code down here, and then you would assign the values from this get IA move respectively. Again, though, this is up to your personal preference. I personally think that that whenever you drift, you probably shouldn't get a movement speed reduction. It's kind of like a way to incentivize drifting. So we'll go ahead and keep the scale value as it is right now for this. But again, if you want to change that to where you do in fact slow down, then the code will be the same as the add movement input. So now that we got our drifting set up, let's go ahead and get our drift boost set up. So the way we're going to go ahead and do this is we're going to go back up to our IA_jump input action. And first off, we're going to get our set drifting to false, drag it down a little bit. And then we're going to open up this drop down menu. And what we're going to do is we're going to get a branch, attach this to setting drifting to false. And then what we're going to do is we're going to get our elapsed seconds. And we're going to drag out of here. And we're going to check to see if our elapsed seconds are greater than or equal to a value. Now this value, first off, get the return node from this conditional check and put it into the branch. This value is going to be however many seconds the player has to hold down the drift button in order to get the drift boost. So for this variable, we're going to call this drift boost held duration. I can't spell. Once we get that done, compile and save, and we're going to and set a default value. For testing purposes, I'm going to set this to 2 seconds. Again, though, feel free to set this to a different timing whenever you're designing, but just so we can test out, let's set this to 2 seconds. Compile this and save. And then what we're going to do is, if this is true, we are going to print string, and the string will be hello. So let's test this out. So we enter our game, we're moving forward, and then we enter drift, hold it down for a couple of seconds, and when you release, you get hello. And now we hold it again, but release it early, and we don't get hello. So now that we got our drift check to work, let's go ahead and get the drift boost to actually work. So what we're going to go ahead and do is first we are going to delete this print string, and pretty much whenever we get a drift boost, we want to increase our movement speed above the limit, and then we want to lower it back down once we finish boosting. So how do we do that? Well, first we're going to get our character movement, and then we're just simply going to drag out of character movement, and then we're going to set max walk speed. Since technically speaking, our movement mode in the character movement system is walking. And pretty much what we're going to do is we're going to put character movement down here, drag out of it, and then we're going to type in get max speed. And then what we're going to do is we are going to add to max speed a value. And then that's what we're going to set max walk speed to. Oops. And then once we do that, then what we're going to do is we're going to right click on this B value, promote it to a variable, and we're just simply going to call this drift speed boost amount. And what this is going to, in this value is just simply going to be however much extra speed you get off of drifting. So this could, so just for debug purposes, let's make this 500. Then once we set our drift speed, just to sell the effect even more since we don't have any particle effects, we're going to get our follow camera, drag it into the event graph, drag out of here, and then we're going to set field of view. By default, our field of view is 90 degrees. So what we're going to do here is we're going to set our field of view to 100. Then we'll delay. Promote this delay, promote the duration to a variable. Call this drift speed boost duration. Compile. And let's go ahead and set the default value for the drift speed boost duration to 1. Once we get that done, we're then going to proceed, and we're going to copy this code. And then what we're going to do is we're actually going to right-click this add node, and unfortunately that doesn't exist for some reason. So what we're going to do is we're going to drag out of max walk speed, and instead we're going to get a subtract node. And what we're going to do is we're going to get our max speed, put that on top, and then we're going to subtract our drift speed boost amount from our max walk speed. And then that's going to reset our drift speed. So once we do that, let's compile, save. Oh, and also, sorry, before we go, make sure you get your follow camera and make sure you set the field of view back to 90. Perfect. So let's go ahead and test this out. Let's go back into the game, start drifting for a little bit. Let's get around this corner, and then we release, and then we get a speed boost, and then we go back down. Perfect. And that's pretty much the tutorial. We have very basic car movement, and in addition to that, we have drifting, and if we all drift down long enough, we have a boost, which is perfect. So if you liked what you saw here, if you want to see more tutorials you can't really find on YouTube, feel free to hit the like button and also hit that subscribe button. Pretty much, and also if there's anything else you want me to talk about and kind of give a tutorial on, let me know down in the comments. I'm more than happy to help out all 99 of you as of this video who are subscribed, and all the others who will subscribe in the future. I just want to help y'all out here with your game dev journey. But yeah. Anyways, one of the things we did do in this video is we did set up the bone structure for different types of cars with all of these variables. If you want to learn more about how you can efficiently track those values and store them, I recommend you check out my data tables and data structures tutorial. That'll be on the end screen as well, so that way it's just ease of access. But yeah, again, if you like what you see, like, subscribe, and let me know what you want to see next from me. Anyways, I hope you all have a great one, and see you later.